Hello everybody, and welcome back to another video. In this video, I will be covering cross product. Now, cross product is a way of multiplying two vectors such that you get a vector which is perpendicular to the other two. Now, if you have taken Physics 1 or many other courses, then you will just think, this is simple, right? Isn't A cross B just equal to the magnitude of A times the magnitude of B times the sine of the angle between them? While this formula is true, in this video we are covering three-dimensional vectors. So in this case, it is much more difficult to think about the angle between them, and in fact it's impossible without using the cross product for the math we are going to be doing. There's ways of determining it. However, we will be calculating the angle between them in part B, which we'll use this formula for. Now, in order to think about these two vectors, let's graph them. So I means the amount you move in the x direction, the j is the amount you move in the y direction, and the k is the amount you move in the z direction. So let's graph vector u and vector v over here. So vector u is 3, 4, -1. So let's write that. So vector v is equal to 3, 4, -1. And vector, or I think that was vector u actually. Vector u is equal to that. And then vector v is equal to -1, 2, 2. Now, as you can see, our vectors are just three-dimensional points in space. If you look at them from here, you could see the plane at which they are perpendicular. And yeah, so rotating this around, vector u, which is depicted right here. Hold up. Oh. Vector u, which is depicted below, is under the x-axis because the z direction is negative. And then, so this is the top view. This is the standard x, y view on these two vectors. So if you weren't looking in the z direction and then looking in the z direction, you can see that they go under. So how would we find this angle between these vectors to use for the formula? We really can't. So let's look at how we multiply them. So we are looking for u cross v. So we are going to write this in a matrix where we have first our I, j, k on top. Then we have our u of x, which is 3, our u of y, which is 4, and our u of k, which is -1. Then under that, we will be doing the same thing for our v. So we have -1, 2, 2. So in order to calculate this vector will have direction, so it's going to be a constant times I plus a constant times j plus a constant times k. So what this constant is the determinant of everything that doesn't get crossed out when you go like this in the matrix. So let's first do this with vector I. So as you can see, our vector, sorry, this is not going away. Our vector I, everything that is perpendicular to it, gets crossed out like that. So we are left with this matrix right here, which is 4, -1, and then 2, 2. So the determinant of this matrix, which is this minus this, So 4 times 2, which is 8, minus negative 1 times 2, which is plus 2, is equal to 10. So this first constant is equal to 10. Now, for our j vector, we will be crossing the 4, 2 out, and then the rest of them. And then we will be writing another 3, and then another negative 1 over here, mapping this matrix over here, this part of it. And the determinant of this vector will be our j. So negative 1 times negative 1 is just 1 minus 2 times 3, which is 6, so minus 5. So the j component is negative 5j. And now for our k component, we can go back to our original matrix, and by crossing out everything that is not k, so we just get this. We get our constant for k. This is supposed to be 4. I don't know why that went away. We get 3 times 2, which is 6, minus negative 1 times 4, which is 4. So this is 10. So our k is 10. This is the answer for our vector u cross v. Now, let's graph this vector, 10, comma, negative 5, comma 10. So we will graph this in vector w, which is equal to 10, comma, negative 5, comma 10, which, as you can see, is going very far away and is perpendicular to both of these vectors. The direction of this is perpendicular to both of these other vectors. Now, let's look at part 2. Part B. Find the angle in between u and v. So, as we know from our formula before, u cross v is equal to the magnitude of vector u times the magnitude of vector v times the sine of the angle between them. So let's rearrange this equation for the angle. So if we divide both sides by u v, the magnitude of both of them, then it cancels out over here, and we are left with u cross v over magnitude of u times magnitude of v, which is equal to the sine of our angle. So the inverse sine of u cross v, the magnitude of this, divided by the magnitude of vector u times the magnitude of vector v, sine inverse, is equal to our angle. So now that we have a formula for our angle, let's calculate these values. So let's say vector u times v, let's state that this is equal to another vector, which I will call w. So the magnitude of vector w is equal to the square root of the sum of its parts. So this would be wx plus wy squared plus wz squared. So looking at our answer up here, wx is 10. So plus 100, or plus 10 squared, which is 100, plus negative 5 squared, which is 25, plus 10 squared, which is another 100. This is equal to the magnitude of vector w, which is, this is all 225. So our magnitude of vector w is equal to 15. So we could plug that in for the top part. This is the sine inverse of 15 divided by. Now, let's look for the magnitude of vector u and the magnitude of vector v. So u is equal to 3, 4, negative 1. V is equal to negative 1, comma 2, comma 2. So the magnitude of vector u is equal to the square root of 9, which is 3 squared, plus 16, 4 squared, plus 1. So this is u is equal to the square root of 26, which is approximately equal to 5.1. Now our vector v is equal to -1 squared, which is 1, plus 2 squared, which is 4, plus 2 squared, which is 4, is equal to square root of 9. So vector v is equal to 3, the magnitude. So this is the sine inverse of 5.1 times 3, which is our angle. Now we plug this into a calculator, and we get that theta equals 78.7 degrees. And that is our answer. So I hope you all enjoyed this video, and please like and subscribe for more. I hope you really like the software I'm using also, and thank you for watching.